Bismillahirrahmanirrahim. Sallallahu alayhi wa alihi wa sallam. Allahumma rabbi zidni ilma. Sallallahu alayhi wa alihi wa sallam. Ameen. Alhamdulillahi rabbil alameen. This is the third lecture of partial fractions. And the topic of this lecture is solution of partial fractions. An important advice: we should be humble. Solutions of partial fractions. We use substitution method to solve partial fractions, and we get the values of x for substitution from the given factors in denominator. Let's understand this concept with the help of this example. In this example, we have three factors in denominator. So this fraction can be split into three fractions. One for this factor, one for this factor, and one for this factor. And we have three unknown constants. So we must have three values of x. And we can get the values of x from these factors. From this factor we are getting minus half, from this half, and from this minus 2. Since we have got these values directly from these factors, therefore the substitution of these values, the order of substitution, is not important. We can substitute these values randomly. The sequence of substitution is not significant in this case. Another example. In this example, we have two factors. One is linear and one is quadratic. So this fraction can be split into two fractions. One for linear and one for quadratic. This factor is linear, so write constant here. This factor is quadratic, so write a linear factor here. Now, for the values of x, consider these factors. From this factor, we are getting minus 2. Since the quadratic factor cannot be factorized, so we cannot get any value of x from this factor. Therefore, we always suppose x0 for quadratic factor in order to eliminate this constant. So remember, whenever a quadratic factor is there, always suppose x0. Since there are three constants, so we must have three values of x. So we need to suppose one extra value of x except these two values. So we can suppose any value of x, but suppose that value which will make the calculation simple. So we suppose x1. Now in this case, the order of substitution is very important. Since we have got this value directly from this linear factor, so we will substitute this value at first. We will substitute this x0 at second and this one at third. This is the order of substitution. First substitute minus 2, then 0, and then 1 to make the calculation simple. Last example. When there is a repeated linear factor with linear factor. So this fraction can be split into three fractions. One for linear factor and two fractions for repeated linear factor. Because we write repeated linear factor twice, once with power 1 and once with power 2. Since all factors are linear, so write constants in their numerator. Now we need three values of x because of three unknown constants. Now consider these two factors. From this factor we are getting 1. From this we are getting minus 2 upon 3. Now we need one extra value of x. So we can suppose any value of x except these two. So the best value is 0 to make the calculation simple. For these two values, order of substitution is not important because we have got these two values directly from the factors. So you can substitute these two values randomly, but you have to substitute this value at the end because you suppose this value yourself. So this is the order. Substitute these two randomly and this one at the end. Well, this is the topic of next lecture, proper fractions. Good luck and Allah Hafiz.